In the year 452, the Roman Empire was collapsing. As the Huns swept across northern Italy and leveled entire cities, locals were forced on the run. With armies closing in, these refugees fled to the coast and took shelter on a cluster of small islands scattered across a shallow lagoon. They were safe from the invading cavalry, but the environment offered no clear path to survival. There was no arable land for crops, no natural springs for fresh water, and the islands were made of a marshy clay too soft to hold the weight of a building. Yet this muddy death trap eventually became the wealthiest and most powerful center of trade in the world. Venice reached this height by building a 1,000-year-old machine that solved a chain reaction of impossible engineering bottlenecks. The first constraint was gravity. To support heavy stone buildings on wet clay, the Venetians imported millions of timber piles from the forests of Croatia. These logs were driven 5 meters deep through the marsh until they hit a much harder layer of compressed clay. By packing these piles tightly together, they compressed the surrounding mud and pushed the water out, turning the soft clay into a solid, load-bearing block. Because the wood was entirely submerged in oxygen-deprived mud, it was sealed away from the bacteria that cause rot. The foundation effectively petrified, creating a stable base that still holds up the city today. Even with these foundations, the ground still shifted slightly over time. For the heavy stone facades and delicate balconies seen here, any minor movement in the earth could cause the entire structure to crack. Architects limited buildings to 3 stories to save weight and used flexible lime mortar instead of rigid cement. Inside, walls were built in a crisscross trellis pattern to provide structural support while remaining pliable. This created a kinetic city, one that survived not by fighting the earth, but by intentionally flexing alongside it. As the population grew, the islands expanded until they began to merge. To connect them, engineers developed these steep stone arches, designed to allow pedestrians to cross while keeping the canals completely unobstructed for boat traffic. This layout separated high-speed commercial supply chains on the water from pedestrian traffic on land, eliminating the congestion that plagued the dirt road cities of the mainland. The height of this system was the Rialto Bridge. To support its 10,000 tons of stone, engineers had to drive 12,000 timber piles into the banks of the Grand Canal. But this economic success created a new crisis. By the time the population reached 170,000, Venice was surrounded by saltwater and had absolutely no drinkable water. With demand far exceeding what boats could deliver from the mainland, engineers converted the empty squares in the center of each island into massive municipal water filtration funnels. They excavated the earth under the squares, lined the pit with a waterproof clay bowl to block the saltwater, and filled the void with specific layers of sand and stone. Rainwater was collected from neighborhood rooftops and channeled onto the tilted tiles of the square. It percolated through the sand layers to remove impurities and pooled in a central basin at the bottom of the shaft. The hexagonal stone wellheads found in Venetian squares today are the visible access points for these gravity-fed filtration machines that kept the population alive. There was one final constraint: waste. 170,000 people living in a compact city generated enough biological waste to trigger a massive disease epidemic. In the 16th century, the Venetians built an underground tunnel network designed to link every building's waste output directly into the canals. Instead of moving the waste manually, they used the lagoon's natural tides. When the water level dropped at low tide, it pulled the solid waste out of the tunnels and into the open canals. Twice a day, the incoming high tide flooded the system, exchanging the dirty canal water with fresh, highly saline seawater from the Adriatic, which acted as a natural disinfectant. By harnessing the moon's pull, Venice created a self-automated sewer system that neutralized biological threats without manual labor. The strained canal shows that these ancient engineering workarounds are not just ruins. They're active mechanisms being maintained to keep the city from sinking. Beneath the romantic architecture and the water, the entire city is resting on a petrified forest from the Middle Ages, sealed in oxygen-deprived mud. Every environmental obstacle the refugees encountered, the mud, the salt, and the tides, was mathematically manipulated to become a part of the city's immune system. As seen in St. Mark's Square, this gravity-based machine is now facing an environmental variable it wasn't designed for: rapidly rising sea levels. Venice stands as the ultimate result of human desperation forced into radical engineering. By manipulating the physical properties of the lagoon, these refugees transformed an uninhabitable swamp into an enduring machine.